Welcome to the day 3 of our Chainlink Bootcamp, the English track. Yeah, it's amazing to see you all here in the third day of the bootcamp, and we have a very special guest for today. We have Darby Martinez. This is our developer expert from United States. Okay, let's go, Darby. Let's start.
Welcome, friends. All right. You got my screen? Yeah, perfect. All right, welcome. GM. We're just going to start off with that. This is the Chainlink Bootcamp and this third section. So what we're going to cover today is oracles, ERC20 tokens, and Chainlink Data Feeds. My name is Darby Martinez. I'm a developer expert, and you can connect with me at Twitter along with my LinkedIn as well. If we can have everybody go over to the pad Rise Up, this will allow us to have everybody follow along while we go into our workshops today, working with tokens and creating a token shop. But first, we're going to handle and learn about smart contract limitations. So at the bottom here, we have a link to the Chainlink blog, and that discusses what is the blockchain oracle problem. I'm going to introduce this problem to you and the limitations of smart contracts. Yesterday, we learned about smart contracts and how powerful they are, but there happens to be some limitations. So, the limitations in a smart contract is that they do not have access to real world data and events. This these blockchains are in their own network, so they cannot connect to these pieces of information, which pose a problem when we are building our smart contracts and building our decentralized web. A blockchain is deterministic. So everything on it is public and immutable. So on the left side here, we have each of these blockchain nodes are running the same computation. This is fairly easy. So if 1 + 1 is the value, all of them can reach consensus because each single node can come to the same conclusion. When you're go to the other side, say you have 3 nodes doing a random call, each random number will come back separate, which then poses a problem, allowing you to not reach consensus. Say you get an API call and somebody calls the weather today, the weather tomorrow, and the weather in different areas. Each area will have different information, which will allow you to not have consensus. And then with the 1 + 1, all of those are separate. So they can't all agree on these API calls, and they all can't agree on what a random number is. Important information that we would like to bring onto a blockchain is market data, retail payments, bank payments, events data, and any number of real world data. These pieces of information will allow us to create smart contracts and build digital agreements that we can all trust and understand. Enter blockchain oracles. So a blockchain oracle will allow us to bring this data onto our chain. And this is what the Chainlink network does, as it is a decentralized oracle network. A blockchain oracle is any device that interacts with the off-chain world to provide external data or computation for smart contracts. This allows us to really connect to the world at large. When we are talking about data sources and external resources, this can deal with anything from sports data to market data, IoT devices, our smartwatches, whether it's Fitbit or any heart rate data, financial data, and then temperature and smart homes. All of these pieces of data can be integrated with our smart contracts to build a more robust Internet of Contracts, allowing us to really build out our dreams here. Next, we have a centralized Oracle, which is not best practices because they are a source of failure and a single point of failure. Essentially, if you had a centralized node that hosted this data, if there was ever an issue with retrieving that data, then it would in turn break the smart contract. Or if you had a malicious node operator that wanted to change data within the smart contract, they could do it, and that ultimately results in bad practice. The solution is the Dawn, so a decentralized Oracle network. So what we're doing here is we're bringing the real world data onto the Chainlink network, and that is being sent to any blockchain, back to the Chainlink network, and then back to real world events. This flow will allow us to have multiple points of data consumption onto our smart contracts, allowing us to have confidence in the data that we're using in the smart contract itself. Enter Chainlink. It's the platform to connect smart contracts. Blockchain or Chainlink is blockchain agnostic. So what that means is it doesn't matter which blockchain you're operating on, whether it's public blockchain, Ethereum, Avalanche, Polygon, or private blockchains, i.e., any financial institution or other institution that may have their own private blockchain. Chainlink is a solution that allows you to connect to each of these networks and allows us to integrate these real world data and events onto our smart contracts. Chainlink is the blockchain Oracle standard. So Chainlink expands smart contract capabilities and it provides secure access to data and computation outside of a blockchain. This allows us to send information, receive information, but also automate our smart contracts, provide random numbers, information like financial data, weather data, and real world events, or any number of solutions. Chainlink, the Web3 platform, introduces multiple services from data feeds and data streams, CCIP, functions, VRF, automation, and proof of reserve. I can elaborate on a few of these, but we will be learning directly about data feeds today. But altogether, all of these services really bolster and improve smart contracts to allow for better reach and access to what we're trying to achieve here. One link that we can go to is dev.chain.link, and this allows us to look at all the resources along with quick starts and demos for developing tools with Chainlink. So in here, you'll be able to go into each of these products and services to understand more, code along, build a workshop, or build a little dApp and understand how the flow of these services work. Next, we're on the ERC20 token, and this will help us understand the standards on the Ethereum network and other blockchains itself. And we will also be looking into Chainlink data feeds and learning about those. The Chainlink data feeds will get data and asset prices in your smart contracts. These are pulled from external sources and have full market coverage, whether it's a decentralized exchange or a centralized exchange. Premium data providers, aggregators, and exchanges all provide value or this data here, allowing us to connect with it. A individual node operator will then pull this information from premium data providers, aggregators, and exchanges to present this to our smart contracts. and it is a volume-based average method, and it's available on many blockchains. A few of the blockchains it's available on are the Ethereum network, Arbitrum, Polygon, Avalanche, and Base. So how this flow works is you have your off-chain, your Chainlink nodes all aggregating price, and then on-chain you have your smart contract. As you can see here on the left side, we have multiple different responses to the data, whether it's 400 or 399 or 398, 401. Some of these may vary slightly. So what happens is it all gets bundled together and aggregated to come up with the price of 400. Chainlink services like data feeds help support the growth of DeFi. So you have Synthetics, SushiSwap, Compound, and Aave, who are all leading industry protocols in this space that utilize Chainlink services like data feeds to provide the data for their smart contracts, whether you're doing swaps with Synthetics or SushiSwap, or you're lending and borrowing with Compound or Aave. This will allow you to understand the digital agreement that you're a part of. And then you can do a deep dive on data.chain.link to learn more, see the different assets that have price pairs, and see which networks that these live on. Here are some references here. Chainlink data feeds, chain.link/data feeds, and then the documentation. So docs.chain.link, which will allow us to have access to the market and data feeds, and then the contract addresses. So as we are building with these smart contracts, we can go and check these smart contract addresses to make sure that they are directly implemented with our smart contract. All right. And then let's address this question. You may, So I have a question here saying, can Chainlink interact with discrete log contracts? To be honest, I'm not sure the technical answer here. If Andre could help me with this, I would assume yes, but I don't know the direct technical response on this. Andre, let's see.
Hey, Daddy. Andre can
Yes.
come back later. You can go forward and you try to answer this later.
Okay, sounds good.
Hi,
We'll
guys.
address this question in a little bit then. Data feeds do provide data for the test nets as well. And Andre will be answering this question in the comment section. So I guess the next step is to take a look at, for us and us only, we have the announcement of the Block Magic, which is the next Chainlink Hackathon. We are giving you access to this early. Please do not share this outside of YouTube or on the greater social networks. This is for us and us only. What this will give us an opportunity to learn more, practice, and build using these Chainlink services and products, while also giving you an opportunity to learn more from partners and sponsors in other workshops. So that will begin on April 29th to June 2nd, about 5 weeks of hacking. And go ahead and sign up here. I'm going to cancel this screen and provide these presentation slides for you here in a little bit. What we're going to do is move over to the pad and rise up. So what we have here, congratulations. Look, we have so many people in the pad. If people following along can go ahead and add their name and their occupation or role, that will allow us to see everybody that's going to be going in the hands-on section with us today. I mean, look at all these individuals here. We have full stack developers, low code dev student. We have friends from Lima, Peru as a Peruvian. Mucho gusto, amigo. We have portfolio and balance sheet strategy analyst, front end developer, computer science researcher. Looks like we have people from a lot of different backgrounds, and I'm so excited to learn more about smart contracts with you guys. Good job handling the flow of the Rise Up pad. It can get a little busy with all the individuals that we have today, but we're going to go through it. At the bottom of the pad, I'm going to start off by introducing Remix and pulling that up. So we have Remix and a link. So remix.ethereum.org. We're going to start off by making sure we're in the right network. So in our Remix, we have our 5 tabs on the left. We've already had an introduction to Remix over the last 2 days, and we will be using this a little bit further. Remix is an IDE, but what we're going to do is we're going to make sure we're in the 5th icon, the deploy and run transactions, and we want to make sure our environment says injected provider MetaMask and that we are on the Sepolia network here, and that can be confirmed with 1115511 as the network. You can see it here at this point. I'm going to make sure to zoom in my Remix just in case people have problems seeing. Does this have a good size for everybody? That's looking all right on my screen. Cool. All right. So what we have here is our Remix. And what we're going to do is I am going to copy and paste some information for ERC20 tokens in our Rise Up pad. So in these sets of links, we have the ERC20 tokens. So ERC20 is a standard on the Ethereum network and then all EVM blockchains that has been agreed upon as best practices for tokens. So opening this link, we have token standards, and you have a few different types of token standards, whether it's ERC20, ERC 721, 777, 1155, and 4626. Today, we are going to be focusing on ERC20 and the ERC token standard. It has tokens can represent anything in Ethereum: reputation points, skills of a character, financial assets, a fiat like currency like US dollars, and an ounce of gold, and more. Tokens can be used across our industry, and we will be learning more about them. Then in our next link, we have the EIP token standard. So an EIP is an Ethereum improvement proposal. And what that has allowed us to do is understand and create these standards like the ERC20 standard. And in this link, you can see simple summary, abstract, why it was created, and then the specifications within it, along with the technical information underneath the hood, allowing us to understand here. Our next link, we have the Contract Wizard by OpenZeppelin. OpenZeppelin is kind of the standard of using the ERC tokens, and this contract wizard allows you to create these tokens kind of on the fly, where you can understand. So let's say my name, Darby token, is the name, and then the token ticker is going to be DRB. So I can just type this into this field here, and it will automatically update the contract here. Whether I want to add features like mintable, or it's burnable, and it's pausable, and maybe I want to have controls over access, roles, whether it's owned or managed, and then upgradability, I can address these changes here in the OpenZeppelin wizard, allowing us to create this and then copy this and introduce it into our smart contract. Back to Remix. So what we're going to do is I am going to share some information with you on the pad. So what we're going to do is go back into our remix. We're going to create a file, and we're going to name that file token.sol. So I'm going to start off by, I have this preloaded here for myself, and I'm going to take this, explain it for you, and I will paste this in the pad. I'm going to first explain it. What we have here is the SPDX license identifier, and this identifies the contract. With the pragma solidity 0.819, this is identifying the compiler for our smart contract, which version of solidity. And then we'll notice that lines 4 and 5, we have import OpenZeppelin, ERC20, and import OpenZeppelin access control. These are important for the ERC20 standard, as we are importing these contracts onto ours without having to copy and paste the entire contract itself. So what we're doing is we're giving our contract access to the functions within these, allowing us to use it. And then on line 7, we are creating our contract. So our contract token is an ERC20, and it has access control. I hear you. I see you. I've posted this in. So now in Remix, you have access to the contract. Make sure to copy and paste from the begin and to the end within Remix. Let's see if I can make this a little bit bigger for you guys as well. Is this better for you guys? All right. So then the first thing, line 8, you have the bytes, the data, it's public, and it's constant. So the minter role, we're getting the hash of the word minter role to create a role within this token, and we will learn through that together. Next, on line 10, we have the constructor, where we are creating the ERC20 with a name and then the token ticker. The name is the first string, and then the token ticker is the second string. What's happening underneath is we're using the function grant role to get a default admin role as the message sender, and then we're granting the role for the minter role as the message sender as well. The message sender would be like me sending information or the EOA sending the data directly to it. The mint function is taking the address, so the address of who we're sending this amount to, and then the amount that we're sending. And then it is public, so anybody can call this. And its only role is the minter role, which is handled up here in line 8. When we are calling this function, we end up doing mint to and the amount. So we're sending to a address, and then we're sending the amount to that address. And then the function, the decimals, is just for us to kind of create this token to be a little bit more based off of what we know already by making it a little bit more like a fiat currency. So if we have 100, what we're doing is we're adding 2 zeros there. So it has, when we type it out, it'll look like 10,000, but really it is 100 because we're making sure the decimal place is at 2. What happens there is in the Ethereum network, it does not handle periods or decimals in numbers. So when you're exchanging Ether, you have 18 decimal places to the right, which is way, and that is how that's handled. We have addressed this, so through this workshop, we will be working with just 2. All right, so what we're going to do is we're going to update our token info. So right here in line 10, we have 2 pieces of information, whether it is the name of our token or the ticker of our token. I'm going to change the name of my token to, no. All right, I'm going to change this to Darby's token, and then DRB will be the ticker. If everybody following along can do the same, then we will get ready to compile and deploy this contract. I'm posting the next steps in the pad for us to follow along. So once again, we're updating the token info, creating our own token. You're updating the token name and symbol on line 10. So on the mint function is public. Yes, we will go through that flow here in a little bit once we mint tokens ourselves. And then especially when we go on to the next step of the workshop, we are going to be instantiating a token shop contract, which we will have to grant roles on as well. So what we're going to do is then compile our contract and we're going to deploy our contract. So in the file explorer, we're going to go to the third one, the Solidity compiler here. It'll look like this. I have mine on auto compile, but if you don't see this green check mark here, you can feel free to hit compile token.sol. Then we will go to deploy and run transactions to this tab here. We have the injected provider MetaMask. We want to be connected here. We want to make sure that this is connected to Sepolia at 111551111. We can see that the account is my account, and I can double check that by opening my MetaMask and checking this account upon, so 4F808, 4F8, last one 667E4. 667E4. This is the same account. what we're going to do is make sure our token.sol contract is selected, and we are going to deploy it. It's going to pop up MetaMask and ask us to confirm this transaction. And now that it's been confirmed, we can see our token here in the deployed contracts. So if I open it up, you can see a list of functions and parameters within the contract. What we're going to do is we're going to copy our token address, which you can copy here with this clipboard button. And we're going to post this in the pad. Good job, Jeff, Sebastian, Killian, Katia, Emily, Susan. Some of you guys beat me to it. Very good job. At this point, do we have any questions? Okay. Nice. Good job. There's so many people joining us today. Good job, Mario, Jason, I see you, Simon, Stanley, Carmine, Henrik, Ben. Now, an important note. I'm going to share this information with you. So at the top here, we have our Chainlink Bootcamp 2024 task form. In this form, this is how you will be receiving certification for this bootcamp. You may have done the workshops from yesterday and the day before, and now we're on the third session. At the third session, you have token address. So if while we're posting the token address in the pad, it might be advantageous for you to post your token address in the form here for the token address as well. While we still have the token address in our clipboard, we're going to do is we're going to add our token to MetaMask. So how this works is we're going to open our MetaMask. We're going to go to tokens. You go scroll down in the tokens tab to import tokens. And here you'll see import tokens, custom token, and the token contract address. That's not it. Give me 1 second. You can grab, once again, you can grab your token contract address here in Remix. But we are going to open MetaMask, open the tokens tab, import our tokens, take our token contract address, and paste that there. And then it will populate the token symbol and the amount of decimals that the token has. As you can see, as I import it, I have 0 DARP tokens, but we're going to import it anyway. Next, we're going to mint 100 tokens, and on Remix, we will walk through this on Remix together. I'm going to paste the information here for you for the next step. So mint tokens, 100 tokens on Remix. You go to deployed contracts, you expand the token, and you function mint. So Let's walk through that together. So we now have the token. We're in the deploy and run transactions page. On the 5th icon, deploy and run transactions. At the bottom, we have our token. We're going to open that up and see our list of functions here. The one that we are most interested in right now for this step is going to be the mint function. We're going to open this up just to make it a little bit easier for ourselves. We have our address and the amount. What we're going to do for our address is we're going to take our wallet address, copy that in there. So I'm going to copy my wallet address by opening up MetaMask, grab my wallet address, copy and paste this to the 2 as, and then that is what's happening right here is this address 2, and then the uint, which is data, the amount. So if we want 100 tokens, we already discussed the 2 decimal places. So we want 100 tokens, and we are in our brain creating, we have this in the amount page. But since Solidity doesn't handle decimals like that, we just have it as 10,000. That was actually 100. We are going to confirm the transaction. It's going to pop MetaMask up, ask me to confirm the transaction. We are going to go ahead and confirm it. Now it's saying mint is pending. So we're going to let the Sepolian network reach consensus. And now we have the transaction in our remix. How can we verify that we have tokens in our account now? There's a few ways to do it. So what we can do is we can do the balance of. So in this balance of, we can paste our contract or our wallet address into the balance of and call it. From here, we are showing that I have 100 tokens. What if I want to see that in my MetaMask? I'm going to open this up, go to my tokens page, go to DARB, see that I have 100 tokens. Next, we're going to be learning a little bit more about data feeds, and we're going to be creating a token shop. I'm going to paste some data feeds related links to our Rise Up pad. And here we have links to the docs or the reference contracts and the data feeds themselves. So we're going to open these up piece by piece. So we have price feeds here. And this is docs.chain.link, allowing us to get information here. So if we go into the overview, we can see the types of data feeds, price feeds, proof of reserve, etc. Getting started. This is where you can examine a simple contract. I'm going to go back to price feeds and exit out of this link. But this is where this information lives for when you're building on your own. Then we have the contract addresses. This will allow us to showcase which networks that this lives on. So say we are operating on Polygon. I can click Polygon here and it'll populate the contract addresses for the data feeds on that network. So say I want to be on the Ethereum mainnet. I want to check the price of Aave to US dollars. I will take this information here and copy and paste that here. And then this has Bitcoin and multiple other assets available in docs.chain.link. And then we have the price feed contract addresses, which is the same page that we were just at. Next, we're going to be creating the token shop. So this is going to help us understand the relationship between our token ERC contract and such. So I'm going to paste this information into the pad. So we have the token shop. We want to go back to our remix, go back to our file explorer, create a new file, the tokenshop.sol. What I'm going to do is create a file with you. So new file, tokenshop.sol, but I'm just going to name it tokenshop1 just for the sake of it. I have it already made. So what we have here is the token shop, and we are going to walk through this together. I'm going to copy and paste this contract information and bring it to the pad and include it between the begin and end. If you following along can go ahead and copy this into yours, that would be fantastic. We're learning so much. We have the SPDX license identifier and Pragma Solidity. These are identifying the Solidity code that we are using and the compiler that we are using. We have a comment here, deploy this contract on Sepolia. And then the next step is on line 6, we have import Chainlink contracts, aggregator v3 interface. What's happening here is we are importing the Chainlink data feeds onto our contract. This allows us to see price and other information. What we have here is the interface of the token interface, and this is pulling the mint function with the address of the account that we want, and then the amount of value that we're sending. And then this is an external function, allowing it to be called outside. The contract token shop has a few variables here. We have the aggregator v3 interface, which is internal, and it's identified as the price feed. The token interface is a public minter. The UINT 256 public token price is 2. So this is $2. One token is $2 because it has 2 decimal places. Visually, you can see that there with the period, but I'm going to take that out because that's not how Solidity works. Then we have the address of the public owner. Then we have the constructor, which is the first function created when we deploy this contract. So when we deploy this contract, we are going to want to give the address of the token address. So the same token address that we imported into MetaMask, that we shared in the pad, and that we put in the forms, we are going to be providing that upon deploying this token shop. This is creating the minter of the token interface is the token address. So it is granting permission of the token interface to mint tokens from our original token.sol. And then we have a comment here, which is just identifying the Sepolia network and that the aggregator for our price feed is ETH US dollars, and that the address is this hexadecimal hash right here. So we would take this. So we have the price feed, the aggregator v3 interface, and we are including the address of the ETH US dollar pair. And then we are making sure the owner is the message.sender. And that is all being handled in the first function upon deployment of this contract at the in this constructor here. Then we're going to the next function, the get Chainlink Data Feeds latest answer. So it is public, so it could be called by anybody. It is a view, so it's not writing anything, and it returns an integer. What's happening here is it usually responds with 5 pieces of information: the round ID, the price, the started at, the timestamp, and the answered in round. For the sake of our contract, we are only interested in the price. So what we have here is some comments and then commas to just identify the price. In other contracts, you may be interested in the round ID or started at or timestamp, whether you're building a financial tool or something along those lines. These pieces of information may be important for the logic of your smart contract. And it's returning this price here. How this looks would be, so we have empty space, comma, price, comma, comma, comma. But we don't need to go too deep there. The next thing, we have the token amount, which is basically understanding whether one token is $2 with 2 decimal places. And this is the function that's making that happen. So what we're doing is we have the amount of ETH sent to this contract. It is taking the ETH to US dollar, getting a value because it's calling the Chainlink Data Feeds latest answer, which is this right here. And it has 8 decimal places. Then what it's doing is we're getting the amount of US dollars, and that is the amount of ETH times the ETH US dollar, which we create here, divided by 10 to the 18th power. So that is ETH with 18 decimal places. Then the next step is the amount of the token. So it is the amount of the US dollar divided by token price divided by 10 to the 8th power divided by 2. So that this math can be a little tricky, just copy and paste here. But what it's essentially doing is it's creating our token, the amount of token to be received at 2 decimal places. Then we have the receive function, which is external and it's payable. This payable value is very important because without this smart contract would not be able to receive any value, whether it's ETH or any other tokens. Essentially, you would send it and it would get locked because it wouldn't have a destination to go to. The uint, the amount token, is equal to the amount token sent by the value of the sender. So if I sent money to this contract, it is taking my value sent and that amount and sending it. Then it is calling the mint function to the address of the message sender, which would be me, and the amount of the token as the response. Then the modifier here is the only owner. Only the owner can send and address this information. And then we have the withdraw function, which will allow us to withdraw the value that this smart contract creates. Now that we've done that, we're going to go through the next steps. So we're going to deploy this contract. I'm going to take this information and send this into Remix for us. So what we're doing is we're deploying our contract. We're selecting the token shop. In the parameter, while we deploy it, we have our token address, and then we're going to hit deploy. So I'm going to walk through this with you as well. Going to open Remix back up, go to deploy and run transactions. We're going to make sure that we are in the injected provider MetaMask, the environment, that we are connected to Sepolia, that my account is the same. And then we're going to go to here in this contract. We don't want to be in, we do not want to select the token interface. What we want to select is the token shop.sol. As you can see here, it is the token shop sol. Then what we're going to do is
What's happened if you select the token interface? You will have the problem that Joss Pond has had. So this is the message and the problem that you have if you select the token interface.
yeah, so you will run into that problem right here. If right here in the deploy and run transactions, this contract tab, it says token interface. We're going to open it up and select token shop itself. And then we're going to notice that this deploy tab is grayed out and it's asking for information. If you remember, during the constructor, we are identifying the token address as information that needs to be given to our contract before deploying it. So what we're going to do is we're going to take our token contracts address and paste it into our deploy tab. And then you will see that this deploy tab itself will light up. I'll just delete it really quick. So it's grayed out. I can't click it. When I paste this here, it lights up, allowing us to deploy it. So I am going to hit transact. It's going to open MetaMask. I'm going to confirm the transaction itself. And then we are going to wait until Sepolia reaches consensus about the creation of my token shop address contract. Now we have the token shop. Yay, it's been created. What we're going to do now is go back to the pad. We're going to share our token shop address with the pad. I can see Nishith, Emil, Joss, Vivesh, and a few others that have beat me to the punch, but are also right here coding along with us. So as we are working together, if we can go ahead and post this, this is also important because this is going to be another task for our task form. And we will go through that together as well. Is that Gilbert's that I saw? It is. Nice. I have Mike. I got Mario, Georgie, Hugo, Alexander, Stanley, Bartek, Juan, Duong. Fantastic. Good job, everybody. Thanks for following along. Thanks for working with us. And I hope you're getting some value here and learning a little bit of something. I'm going to pull the task form back up and just show you that as we go to session 3, we have our token shop address. You just go ahead and make sure that once your token shop is deployed, you can paste this token shop address to your task form. This will help us know where you are, whether you have any problems, but also help you get you the certification for this boot camp as well. Now I'm going to go back to the bottom, and we're going to be walking through the process of granting a minter role to the token shop. So I'm going to take All right. Yeah. I'm going to take this information and post it at the bottom of the pad as well for the next steps. So, good job, everybody. Looks like we got quite a lot. So we have 591 and then 691. We have almost 100 people working and deploying this token shop with us as well. Congratulations. Give everybody their own little pat on the back, round of applause to yourself. Good job, friends. The next step, we're going to be granting a minter role to the token shop. So how that works is we have our token and we have our token shop. In the token, we're going to open this up. I'm going to minimize the mint function. I'm going to minimize this balance. I'm going to click this blue button here for the minter role. We're going to see an aux9f 2D. This should be the same for all of us, as what's happening here is we're getting the Keshak or hash of the string value minter role. So everybody should be the same. But if it is different, that's okay. We're just going to follow along this here directly. We're going to copy and paste this minter role. Then we're going to run the function grant role. So what we're going to do is we're going to paste that value from the minter role into this role here. And then it's asking for an account. Does anyone know which account it should be? I don't know if I have any comments here. The contract address.
Yes, I will be here
Perfect.
to answer that, Darby. So, Manuel, if you'd like to mint 10 tokens per 0.1 ETH, it depends of the token price that we defined inside the token, not in the token shop. Okay, so this will be the rule in the token. We define the price of the token in USD. If we define the price in it, can be on this way, but like to us doesn't make sense to do in that way because we'd like to use Chainlink Data Feeds to do the conversion. So it's better to get it and convert to USD.
Thank you, Solange. Excuse me. So then we're in the grant role function. We have the role, which we got from the minter role by copy and pasting this value here once we called it. Then we have the account. And this account here is going to be our token shop address. So we can go ahead and copy that from our deployed token shop contract or the same value that you pasted in the forms along with the pad rise up. And then we're going to grant role. Hit transact, pulls MetaMask up, confirm the transaction, and have it move forward. We confirm it. Once it's still pending, but once it goes through, we can confirm it by checking has role. So take the role information here and then take the contract address of our token shop and paste it here. This should pull back a Boolean value of true, which will confirm whether or not your token shop address now has the ability to mint tokens from your token address. Now we are going to go to the token shop. We're going to get Chainlink Data Feed latest answer. This here is the value of ETH currently based off of the Chainlink Data Feed ETH pair. We want to do is to see the value here, we can move the decimal over 8 points. So let's take this to the pad so we can all follow along together. So the data feed value was this. So we are going 8 decimal places to the left here. 1, 2, 3, 4, 5, 6, 7, 8. And we can paste or post a decimal here. So as we can see the current value of ETH is 3353.929. Add some numbers. This is the current pair. And the next step is we're going to buy tokens from ourselves to the token shop. So what we're going to do is I'm going to take the token shop address. I'm going to copy this. I'm going to open up MetaMask. I'm going to send some value. I'm going to paste my token shop address into my MetaMask. I'm going to send 0.01 Sepolia ETH to myself, or to the token shop address. And what it should do is mint that value back to me in my wallet. So before I do this, let's just take a little mental note about the amount of DARB tokens I have. I have 100 DARB tokens. After I do this transaction, you should see more. What that value is to 0.01 ETH, we will see in a second. So I am going to send this value to the token shop. I'm going to 0.01 Sepolia ETH. Going to send this. I'm going to confirm this transaction. It's pending. It's pending. It's been confirmed. So when I open this token tab, I should see the value of the DARB tokens in my wallet have changed. As you can see, 0.01 Sepolia ETH has minted me and sent back 16.76 DARB tokens were sent to my account. Now, what I'm going to do is I'm going to take I'm going to send some value to some of our contracts here and see if I get any value. So I have George P. First thing I'm going to do is I'm going to find George P's token address. I'm going to copy and paste this. I'm going to open up my MetaMask. I'm going to import one of his tokens. I'm going to see if is Kaka. Kaka. I'm going to import this. I have 0. Now I'm going to go to George P's token shop. I'm going to copy and paste his. from there, I'm going to send George some money. Let's do 0.07. I like the number 7. I'm going to send him 0.07 Sepolia ETH. And now that contract is pending. And what I should do, what I should receive is 0.07 ETH worth of George's tokens. It's confirmed now. So then I now have 116 KA tokens. Do we have any questions with where we're at this point? Let's take a look at the chat. Manuel. All right, I see you. How does the contract estimate how many tokens to mint? Let's go look at the code. So here we have the token price. We've set the token price to be $2. We're getting that value from the Get Chainlink Data Feeds latest answer to figure out what the value of ETH to US dollars is to get the price. Then we do the math to get the current price of Chainlink of the ETH US dollars, divided that by, get the decimals out, and then divide it out to make it so each one costs $2. And then from there, that is being calculated for how many tokens are minted based off of the value sent. You want me to go buy more of George's tokens? I could do that. All right. So what I did originally was I went to George's token address. I had to search it, but it's right here. I took his token address. For me to even be able to see it in my MetaMask, I had to import his token, which you would have in your tokens tab in MetaMask on the bottom, import. I pasted his contract address. It's already been added, so I can't follow this again. But ideally, I imported his token into my MetaMask so I can see it. Then it populated here. What I did then was I went to the same address for George for his token shop address, and I copy and pasted his token shop address. From there, I opened MetaMask. I hit the send button. I pasted his token shop address. I defined the value in which that I wanted to send him. So 0.07 was what I sent last time. This time I'm going to send another 0.01. George, you're cleaning up today. Then I'm confirming this transaction. And then once this transaction goes through, I should be able to see that this token, Kaka or KAK, creates more. So now that it's confirmed, I see that I've received another 16 KAKA tokens back. No, I own those tokens. I have minted them from his token contract using the token shop. So we called the token shop we gave the token shop access to the minter role of the token.sol contract itself. So now the token shop can mint tokens from George's token contract. I sent the token shop value. It then minted from the token contract and sent those to my address. Token amount. Let's take a look. Which two lines were you? So the decimal bit. Excuse my remix. It's looking like let's reload this. Apologize there. All right. So back here. We are having issues understanding the two lines in the function token amount don't get the decimal bit. So it's kind of tricky due to the math here, but essentially we're getting the amount of ETH times the ETH priced in US dollars divided by 18 or 10 to the 18. So what we're doing is we're taking the 18 decimal places out of that. Then the next is the amount in US dollars divided by the token price, divided again by 10 to the 8th power divided by 2. And once again, it's kind of tricky math, but essentially we're boiling this down so there's not 18 decimal places on the right of our value, and we're making it a little bit more user friendly by making it closer to fiat, where it has 0.02 or 0.2. It has 2 decimal places to the right of the value. So if we have 100, the value itself looks like 10,000, but it was 100. So essentially, the right 2 decimals, or yeah, decimals are values. I still have information on the pad. Point 0.01 Kaka gave me 16 tokens. 0.07 gave me 7 times 16. So it should value out at around 116. I thought that was a little weird myself, almost like I minted 100 of his tokens to begin with as well. But somehow the math just happens to work out where those values look similar. Let's take somebody else's token. Let's walk through somebody else's token. So let's go find, shoot. It does look like some tokens. All right. Nice. If let's use Sock the Bell. I'm going to copy and paste his token address. It looks like we lost a bunch of the token.sol addresses. So I'm going to use this one here as another example. I am going to open MetaMask. I'm going to import a token. I'm going to take the value that I had, SAK, S-A-K. Next, I'm going to import it. Successfully been imported. I can see it here. Now I'm going to find Saktival's token shop address, copy and paste that myself. Open MetaMask. Going to send value here. 0.01. Going to send it. Confirm my transaction. Absolutely, Solange. The size okay now? Let's do one more. Look a little better? It looks a little better. Perfect. Andrew, is that your token address so I can import it? Perfect. I'm going to go with blue and suit. So I have the Munich token. I'm going to copy that. Going to import it in my extension or my MetaMask token. Import. That is why. Now, MUC. Now I have that. It's been imported. Now I'm going to take his token address or token shop address, and I'm going to send value. Paste that there. Let's do thanks for posting this in chat. You're getting 1.1 Sepolia ETH now. I got size and large. Confirm the transaction. And we should see a bunch pop into my MetaMask here. Waiting for the contract to go through. It's sent. So we can see I lowered in value 0.1, but I received 165 Munich coins. Thanks for your transaction. Kind of lost on the token shop address. How can I help? How can I help? You absolutely would. That is exactly how you would. So the question is, so for me to get the Sepolia ETH that my token shop has, I would call the withdrawal function of the token shop is correct. And only you as the owner of the token shop should be able to withdraw the value there. Andrew, I'm coming. All right, token, copy. I'm going to open up my MetaMask. I'm going to import your token. That looks like the one that I have here, Andrew, is your token shop address. It's asking me for a token symbol. Could you please post your token address for me so I can import it? I can show you how that works. So in MetaMask, you can go to prior transactions. You can see your past activity. So we can see that I have been interacting with a lot of contracts here. Last thing I did myself was grant roll, but then I have all these contracted iterations, which I can also view on the Block Explorer as well. We learned yesterday about the Block Explorer, and the day before we had some initial insight into the Block Explorer. So real quick though, we can we can see that my address 4F808 sent to this contract. We transferred about the value of 16 Saktivals tokens, or SAK tokens, is what I received back. The value initially sent was 0.01 ETH. The transaction fee was this here, and the gas price was this here. I can go into more details and understand more, but that's how that works. Let's get back into Remix. Yes, blue and suit. What you can do is you can go to your token shop contract and hit withdraw. From there, you should be able to withdraw the 0.07 and the 0.01 Sepolia ETH, totaling in 0.08 Sepolia ETH back to yourself. Let's take a look at the pad. See if I have any questions here. All right, Steve, I see you have the token and the token shop. I'm going to copy your token. I'm going to import it into my MetaMask. I'm going to buy some from you, buddy. STH is the name of your token, or the token symbol. We're going to import it. Now that I have it in my MetaMask, I'm going to go to your token shop address. I'm going to send you some value. I'm going to paste that directly in. I'm going to do 0.0777. All right, trip sevens. Next. Going to confirm. And I'm going to wait for that to respond. Mario, you're next. I'll go through and send more value to anybody that I like the way that you guys have set this up with the token and the token shop. Mario and Steve, the way you guys did that was good. It's easy flow for me to follow up. So while we close out our time here, I'll be sending some value. And if these are populated together like this, we'll I'm just gonna accumulate a whole bunch of your guys's minted tokens. Thank you. Now that I've sent, let's double check. Now I have some SIP tokens. Mario's up. Mario, let's see what the name of your token is. You're gonna import it. MRO. It's a token symbol. I've imported it. Next, your token shop address. Extensions. I'm going to send you some value. Let's do 0.08. I'm sending that to you, buddy. Andrew, you're next. You absolutely can. Let me hook this up. So Darby token shop. My token is going to be because I lost it. Let me get this up for you. Should be able to pull this. Darb. I appreciate whoever is already a top Darby holder. You're a homie for sure. Token shop. Let's go back to mine. Contract creation. Nope. Without getting lost in myself. I'll populate this in a second, but let me continue to send value for you guys.
Hey, Darby,
Yes.
do the people need it? Is this?
What was that?
They need it on Sepolia? Is this?
ETH on Sepolia. Where's
They
this
no
question?
they this is my question to you. How the people good on that, because our workshop faucet is working if they need that, okay?
Got you. All right. Yeah. So if you need Sepolia ETH, at the top of the pad, I posted our faucets. So we have the official Chainlink faucet. So faucets.chain.link. You can find that link here. And then for the sake of these workshops, we also have a workshop faucet, which you can see here. I have included that information at the top of the pad as well. So you can go ahead and, oh yeah, smart. Thanks for adding the password there, Solange. Appreciate that. So the password for the workshop function faucet will allow you access if the traditional faucet poses you any problems. I would get it from Remix, but since I reloaded my page, I don't have this up. It's not populated. I could go
Do
back
you
and dig
need
into it.
the address of your contract? Is this?
Yeah.
Okay, go to your MetaMask wallet
Yes,
and
ma'am.
open any transaction on Block Explorer. Yeah, any of that. Go to your wallet. In fact, we need to go to your wallet. Yes. Find the last contract deployment over there in the transaction part.
Contract creation.
Yes, probably this is the token shop. The other is the
It's
token. Yeah,
perfect.
these are both. Open the two transactions. Is this the token?
Token.
Okay. You have the address and you have the token shop. Yoo-hoo.
Derby. Token. All right. Now, second one.
The contract is upstairs. Contract go a bit up. Yes, here.
Perfect. Thanks for that. Cool. Because of the monkey emojis, I got you, Eric. I like that.
Give me 1 second. My headphone just.
So, what about to create your token and your token shop? Did you like it? And yes, remember that you can share in the social networks that today you learned how to create a token. And you know that I used to say that create a token it's so easy, but to make the people believe that your token has some value, it's another history. And I think that is back.
Yeah, I'm back. Can you hear me fine? Thank you. Cool. Can I repeat the process for sending tokens to ourselves? For sure. So, since this is mine, I want to grab my token contract, copy and paste that, go to my MetaMask. I'm going to import it. I already have mine imported, so it's going to say that the contract token has already been added. But essentially, then I'm going to the token shop. I'm copying that address. I take the extension of MetaMask. I hit send. I paste my token shop address. And then I send it some value, whether it's 0.01 Sepolia ETH. That's that. It's the same flow for sending tokens to each other as well. And then I confirm the transaction. Can I show you withdrawing the amount once? Absolutely. So, token shop. I'm going to take my token shop address. I'm going to open Remix. I'm going to open up my token shop address. I'm going to hit withdraw. Let's take a look at my MetaMask first and see how much value I have. 0.2088. When I hit withdraw, it's going to ask me to confirm this. I have 1 ETH here. Thanks. This was quite nice. It's pending. It's pending.
And could you go to the function withdraw to in the contact to them to be sure that they understand what's happened?
Yeah. So external, it could be called anywhere. but only the owner can call this. So only the owner of the contract, i.e. myself, can call this. And then it's payable to the owner, and it transfers the address of this balance here. And after I've called that, let's take a look. Let's see. I should have 1.2 ETH now because I withdrew it from my contract. This token shop balance is there a way to refresh this? All right, no, it refreshed on its own. So it lagged a little bit, but I could see the balance here in my token shop, and it had 1 ETH in it. When I hit withdraw and transacted, it sent that to my account, and now I see that in my MetaMask. It's been reflected here. Short answer, yes, Ken. You always pass a gas fee to withdraw your tokens. Yes, we're operating on a test network, so while there is a gas fee, it doesn't have real value, but the answer is yes. For any change in state of the blockchain or block space, we pay gas, whether it's transactions, posting information, or providing value in any way. There's gas required as kind of rent in the system.
Yeah, congrats, Darby. I think your session today was amazing. And it's so cute to see the pad with the students' names and everything done. I will share my screen as well. Wait a minute. You can share, but I will change to mine. Like, look at this. This is so cute. It's amazing. I'm so proud of you, and I'm so proud of our students as well. It's really amazing to see how you are learning, how you are doing the contents with us, how you are coding along. And this is, you are learning day by day, creating smart contents. Start to learn Chainlink today. And oh yes, I'm so happy with everyone. I think we are finishing now. Darby, would you like to say some final words?
Thank you so much. Thanks for the opportunity. Thanks to the Chainlink Labs team for putting on this boot camp. Thank you for everybody in attendance that wants to grow and learn. What's great about this is when you stay committed over long periods of time, you can continue to learn and grow. It wasn't just 2.5 years ago or so that I was a student at one of these smart contract boot camps run by Chainlink years ago. And the fact that I got the opportunity to come on and teach a little bit and share some of the knowledge that I've accumulated and help out in any way, it's been an amazing experience. So thank you. Stay committed. And if this is what drives your passion, keep going, because it's worth it. Thank you.
Yes, thank you so much, Darby. I'm so proud of you. You are part of the history, and you are an inspiration to everyone exactly because you started in a bootcamp, and look you now, where you are now. So I'm so proud of you.
Thanks again. Appreciate it very, very much.
And remember that we have our hackathon. So you are learning now from zero, creating smart contents day by day. We are finishing this on 12th of April. After that, we have the hackathon starting on April 29. During that time, you can form a team with the people that are here in the bootcamp, and you can participate in the hackathon, create an amazing project, and learn more advanced topics, because in the hackathon we have more advanced workshops. So I hope to see you over there. And remember, this link it's only to us now. It's not public yet. So you are the first to know that.
Do the boot camp or do the hackathon. It's worthwhile. Even if you think you should grow and learn and you might be doubting some of your capabilities or something, definitely go through it. Definitely build a team. You can only learn like that by putting yourself in the uncomfortable space. So highly recommend it. I got the opportunity to be a part of 2 prior hackathons, and I love helping out any way possible. Definitely go through and shoot your shot. Try it out.
And this is bye everyone. We are finishing now.